to natural log of x. This is natural log of x quantity squared. We're squaring that whole amount, not just the x. So one substitution I can do is, I want to make this look simpler. Well, derivative of e to the x was pretty simple. So my first substitution, we will let u equal that exponent, the 10 plus natural log of x quantity squared. But natural log of x quantity squared, we would need a product rule to do, so we can either do that or we can do a second substitution, and we can say let w equal natural log of x. So then we have w is natural log of x. U is now 10 plus w squared by our substitution. And then y is our desired just e to the u. And we can differentiate each piece. So derivative of w with respect to the variable x is 1 over x. Derivative of u with respect to the variable w is 2w. And derivative of y with respect to the variable u is still e to the u. So dy dx is going to be dw dx times du dw. So notice the dw's are already going to drop, times dy du. The du's will also drop, so we'll have just a dy upstairs, just a dx downstairs like we wanted. So 1 over x times 2w times e to the u, and then we just use a little back substitution. So 2 times w is natural log of x times e to the u. U is the 10 plus natural log x quantity squared. And downstairs we have our x still. And there's not really anything in the way of cleanup that we can do here. We definitely can't do any canceling here. X is a factor down here. X is part of an argument of a natural log up here. We cannot cancel those out. So that's as far as we go finding that derivative. So occasionally it is up to us to pick out what u is. Occasionally they will just hand us the u. Alright, so we have you all try one of these out, and then we're going to go ahead and wrap it up here. So you're going to differentiate y equals h of x equals natural log of 1 plus e to the x quantity cubed. So go ahead and try to differentiate that one, and just go ahead and unpause it when you're done. Okay, welcome back. So h prime of x, this is going to be a general power rule to start with. So we have 3 times r natural log of 1 plus e to the x quantity, now down to the second, times the derivative of natural log of 1 plus e to the x. So I'm going to temporarily let y equal natural log of 1 plus e to the x, and we'll let u equal 1 plus e to the x. So dy du, y would be the natural log of u temporarily. So that would be 1 over u, and du dx is e to the x, derivative of a constant, always 0. So our d dx here is e to the x over u. So that's e to the x over u was 1 plus e to the x. So then h prime of x, 3, by natural log of the quantity 1 plus e to the x, quantity squared, times our derivative of that last part. So that's times e to the x over 1 plus e to the x. Can't cancel those. This is a factor. This is part of a term, not a factor. So about the only cleanup they do on this is they may write it as one single fraction. So they might write it with the first powers together, h prime of x, 3e to the x, times what we have, squares of natural log of 1 plus e to the x, quantity squared, and 1 plus e to the x downstairs. Other than that, that would be about the only cleanup to do on that problem. Okay, so let's see. Let's try maybe one more example together, one more you try it, and we'll call that a section. So together we'll do y is equal to, let's see which one I want to do. We'll try that one. Natural log of 5x to the 4th minus 7x squared plus 2. So for this one, we have to pick out our own u. I would let u equal the 5x to the 4th minus 7x squared plus 2. So y is then natural log of u, and u is 5x to the 4th minus 7x squared plus 2. So dy du is 1 over u, du dx, derivative of just that polynomial. So 20x cubed minus 14x. Multiply those guys together and put our original variable back in, and we have our derivatives. So 20x cubed minus 14x all over u, just 20x cubed minus 14x over u is the same as the 5x to the 4th minus 7x squared plus 2. Doesn't look like we have any useful factoring that we can do on that one. We pull a common factor from the top, but wouldn't really have any partners in the bottom, so that wouldn't be as far as I'd go on that one. Okay, so we all try one out. So let's see, so I'll have you all differentiate a y equals, let's see, or no, we just did a natural log, we'll do the other one. So y equals e to the 7x to the 5th plus 9x plus 1. So see if you can find y prime or dy dx. So go ahead and try that one. Welcome back. So here we would let u equal 7x to the 5th plus 9x plus 1, which would make our y equal e to the u. So du dx, 35x to the 4th plus 9, dy du stays at e to the u. So dy dx is the product of those. Since we have more than one term, we do need parentheses here. So 35 x to the fourth plus 9, close it on up, times e to the u, and then back substitute, get rid of our u. And dy dx, 35x to the fourth plus 9, close it on up, times e to the, back to the original variable, so 7x to the fifth plus 9x plus 1. Okay. So some homework problems that I would recommend trying out in, this is section 3.4. If you're in the current edition, I would try 1 to 67 every other odd. If you're in the old edition, he had a couple extra exercises in there. You can go all the way to 71 every other odd. Okay, so next video to be uploaded soon. I would try to spend approximately 2 days or so on this before you dive into the next section. Thank you very much, and hope to see everyone in person again soon when this is all over. Stay safe out there.